temperature and pressure conditions. As a result, the rock's composition, texture, and structure are all altered. Several important factors influence metamorphism. The first is temperature, which provides the energy needed for chemical reaction to occur. The second is pressure, which compresses the rocks and can align mineral in a particular direction. Another factor is chemically active fluids, such as water containing dissolved ions. These fluids can speed up chemical reaction and help transform elements within the rocks. Together, these factors control how the rock changes during metamorphism. There are two main types of metamorphism. The first is contact metamorphism, which occurs when rocks are heated by nearby magma. In this case, temperature is the main factor, while pressure is relatively low. The second is regional metamorphism, which occurs over large areas and involve both high temperature and high pressure. This type is commonly associated with tectonic processes such as mountain building. These two types shows how different geological environments can produce different metamorphic changes. A common example of metamorphism is the transformation of limestone into marble. Limestone is mainly composed of calcium. When it is exposed to heat and pressure, the calcite crystals undergo recrystallization, meaning they reorganize into larger and more stable crystal. This process forms marble, which is harder, denser, and has a more compact structure compared to a limestone. Metamorphism also changes the texture of rock. In some cases, mineral becomes aligned due to pressure, forming what is known as foliated texture, which gives the rocks a layered or banded appearance. In other cases, rocks may remain non-layered, depending on the condition and mineral composition. These texture changes are important indicators used by geologists to identify metamorphic rocks. Metamorphism is important because it plays a key role in the rock cycle, transforming existing rocks into new types. It also contributes to the formation of valuable natural resources, such as marble and certain minerals used in construction and industry. Additionally, studying metamorphic rocks helps scientists understand the condition and processes occurring deep within the earth. In conclusion, metamorphism is a key geochemical process that transforms rocks through heat and pressure without melting it. It shows that rocks are not static but continuously changing within the Earth's system. And that's all from me. Thank you for listening.
Hi guys, my name is Muhammad Koyum bin Muhammad Saipul. My number metric is E25A3585. So today we'll talk about geochemical process in water, which is precipitation. Have you guys heard about it? You guys might be wondering, what is precipitation? Precipitation is a process where chemicals are added to water to convert dissolved substance into solid particle. This solid particle can then be removed by settling or filtering. So how precipitation process happen? Precipitation process happen when chemical reaction between a dissolved contaminant and added reagent produce a solid compound whose solubility limit is more than contaminant, causing tiny solid particles to nucleate and grow, which are then removed by settling or filtration. Just imagine as a calcium bicarbonate as our contaminant, plus with our sodium carbonate, which is as our reagent. When these two chemical reaction react, they will produce a insoluble byproduct, which is calcium carbonate. This calcium carbonate later on can be filtered or settling. There is so many importance of using chemical precipitation in our industry, such as ensure safe drinking water by removing hardness and reducing disinfection byproduct. Moreover, in the chemical precipitation manage our industrial wastewater in mining to meet environmental regulation. Lastly, chemical precipitation enable recovery of valuable metal from waste stream to reduce our environmental impact in our ecosystem. Next, we're gonna talk about challenge of using chemical precipitation. Firstly, selective precipitation. When multiple contaminant exist in water bodies, is it difficult to remove only the specific target without affecting others? Secondly, waste generation. The process generates solid waste in the form of precipitate. If we don't carefully manage it, it will become harmful to our ecosystem. By using this, proper disposal or treatment of the solid is essential to prevent secondary pollution. Thirdly, chemical doses. Achieving optimal precipitation often require precise control of chemical doses and reaction condition. Overdosing or underdosing can lead to ineffectiveness or incomplete removal of contaminant. And lastly, pH control. Managing pH is critical in many precipitation reactions. Monitoring and adjusting pH levels can be complex, especially in large-scale application. Okay, lastly, we're gonna talk about application of chemical precipitation in our industry. In wastewater treatment industry, municipal drinking water treatment company usually softening their water by using sodium carbonate to remove iron calcium from calcium bicarbonate that can cause hardness in water. Calcium bicarbonate usually react with sodium carbonate to produce calcium carbonate, which is insoluble product. Same case as water softening. In wastewater treatment, chemical precipitation is utilized to remove phosphorus or iron phosphate to prevent eutrophication that can cause a massive bloom of algae that can kill organism and fish in a water body. So to prevent this, they usually add alum or known as aluminium sulfate that can react with iron phosphate to produce byproduct of insoluble aluminium phosphate. Meanwhile, in mineral and mining industry, chemical precipitation process usually being used to remove heavy metal solution. Example of heavy metal solution is copper. In order to remove copper, we must use sodium sulfide. When sodium sulfide react with iron copper, they usually create or produce insoluble precipitation, which is copper sulfide. Lastly, in mining operation for mining heavy metal, there is a high chance possibility to generate very strongly acidic or alkaline wastewater. To prevent this, usually miner using a calcium hydroxide to neutralize wastewater before discharge of their operation.
Hi, my name is Nur Afika Ania binti Mazuki, number metric E25A3679. Today, I will explain about geochemical processes in water, focusing on dissolution. First, dissolution is the process where a solid substance, also known as a solute, dissolves in a liquid called a solvent to form a solution. In most natural systems, water acts as the solvent because it is very effective in dissolving many minerals. Now, how does dissolution happen? When water comes into contact with rock or minerals, it reacts with them, especially if the water is slightly acidic. For example, rainwater contains a small amount of carbon dioxide which forms weak carbonic acid. This acidic water can dissolve many minerals such as calcium carbonate found in limestone. Okay, next, why is dissolution is important? Dissolution plays a major role in shaping the Earth's surface. It contributes to the formation of features such as cave, sinkhole, and underground drainage system. It also helps transport dissolved mineral through rivers, land, and groundwater. In addition, dissolution affects water quality. The mineral dissolved in water determine whether the water is hard or soft, and they also influence its chemical composition. This is important for drinking water, agriculture, and industrial use. Finally, dissolution is closely connected to other geochemical processes. For example, once minerals are dissolved, they can later form new solid materials through precipitation. This shows that geochemical processes are continuous and interconnected. In conclusion, geochemical processes in soil, rocks, and water are important in shaping the earth and maintaining environmental balance. Processes like weathering, dissolution, and mineral formation control how elements are distributed in nature. Soil provide nutrients, rocks supply minerals, and water help transport them. Therefore, understanding these processes is important for sustainable development and environmental protection. That's all from us. Thank you.